Hello, hello. I'd like to talk about the 1902 Montagne Pelée eruption. May 8th this year marks the 120-year anniversary of this eruption, and it was a severe catastrophe, one of the really bad volcano eruptions of the last century. And I'd like to summarize this a little bit and make us all think a little bit about how we can learn from this and improve on things in the future. So I'm gonna share my screen, and I have prepared a little bit of material here. And here we have my presentation, and it's about analyzing a catastrophe. So here we'll start with a little bit of an insight about the location. And Montagne Pelée is on the island of Martinique in the Lesser Antilles. And here we have the Lesser Antilles arc, and there's several active volcanic systems. Currently, I'm working with a friend on Guadeloupe, and I had a PhD student there a while back. And here is Montagne Pelée on Martinique, and the island is a little longer. It's got two volcanoes, actually, an old one in the south and a younger one, Montagne Pelée, in the northwest. So here's the entire island arc here. It's the only subduction zone in the Atlantic Ocean, in the central Atlantic Ocean at least. And this means that there's old volcanic crust that's subducted under the arc, and it gives rise to these volcanoes there. So here's a map, and you see the terrain in the north is where the active volcanic systems are, and in the south we have a more flat terrain, and this is older volcanic systems. So here a picture of the city of Saint-Pierre, and Montagne Pelée in the background. It towers over the city, and the city is a beautiful spot, but it's much smaller than the city back then in 1902. The devastation has caused the city to never really grow back to its former size and strength. And we'll talk a little bit more about this later. So here another image, an aerial image of the volcano. It's rather green there, it's lush, it's fertile, and this is why people settle there, of course. And there you see the city is at the foot of the volcano. It's only about 6 kilometers away from the peak, so it is pretty close after all. And here's a few more impressions. I mean, beautiful beaches. And this splendid mansion here is where I was at a conference a few years ago. And I was there as a young researcher on a European Union stipend. And this was rather thrilling, to be honest, for me. And this is where much of the material now comes from that I'm going to present today. So here is an older image of Montagne Pelée volcano with a somewhat larger city of Saint-Pierre. And here's an aerial image of the dome. There's two domes visible right now. There's the 1902 dome and also a later dome from the late 1920s. The one on the left is the 1902 dome, and it sits inside this crater on Montagne Pelée summit. So, and let's talk a little bit about Saint-Pierre around 1900, just before the eruption. And I need to close the window now. There's a few students outside. And here we have the area of devastation marked with a black line. This is this area here. And here we have the crater area of the volcano. And here's the city of Saint-Pierre. And at the time, it was a major port. We'll talk a little bit more about that later. But there were several large ships there at the time, and we have some reports from these ships. The village of Montrouge, it will come to be important later in the talk. It was located about here. So, and the city of Saint-Pierre was the colonial capital of Martinique at the time, and it was also referred to as the Pearl of the Lesser Antilles. It was founded 1635. The city was located only about 6 kilometers away from the peak of the volcano, and several rivers descend from Montagne Pelée, supplying the city with fresh water, one of the main reasons why people settled there. So it was a thriving city. It had an official population of about almost 20,000 people in 1894 and 26,000 people in 1901. So it was growing. And a small elite, a colonial elite, was the ruling class in the area. The city was quite well developed. It had a cathedral, a hospital, a theater, and many imposing public buildings. The theater, there's an image of it in the upper right, up here. And there's also a monument, this monument here, to Josephine, the wife of the Emperor Napoleon. And by 1895, it had electric lighting, which was rather unusual in those days. So culturally and technically really advanced and very important. So the main street, Rue Victor Hugo, here's a drawing of the main street, and here's a photo from the time. I'd like you to note that there was actually drainage systems at the side of the road, which was really kind of advanced at the time. And here you see it as well. So there was some planning that was integrated into the city's kind of functionalities. And this was very important, making this a thriving place. So here is a few impressions: downtown Saint-Pierre, marketplace Saint-Pierre, and here the stairs up to the mayor's house and the town hall. And all of this looked rather neat to me, and or looks rather neat. And this was a well-populated, well-developed, thriving city. So in the suburbs, it looked a little like this. And of course, local populations were often employed in some of the colonial households. And here we see that there was washing going on in the river here, done by local women. And then if we look at the port, here we have the Rue Victor Hugo, that's the main street I mentioned before. And here we have the ships in the harbor waiting to be loaded and unloaded. And there's a few more here. So this is the volcano in the background. Here we have the cathedral, and the Rue Victor Hugo runs parallel to the shoreline. And here we have ships in the harbor, and quite a lot of them from all over the world, really. So, and sailors also from all over the world. The major industries at the time was sugarcane, bananas, and importantly, rum. And here are some barrels with rum. Rum is obviously a product from sugarcane. And the whole northern Martinique is famous for its rum, spelled with an H. And that's important because it marks a different type. I'm not a specialist for that, but the rum spelled with an H is particularly strong. And I couldn't help when I was there to purchase a bottle of it. As you see here, it's got very high alcohol content, and it's not made from the leftovers of the sugarcane. It's rather made from the sugarcane sap itself, and that makes it particularly strong. That's my understanding of it. So alcohol content goes up to 60 volume%, and we'll talk a little bit more about that later because it actually played a role in the catastrophe, to be honest. So now let's talk a little bit about the volcano. The sequence of events is important here. Prior to 1902, there was eruptive events. There was activity in 1851 and in 1792, but each time only minor fumarole and harmless ashfall activity. Knowledge existed of a major eruption prior to the arrival of the French colonial settlers in 1635, so it was before that. But this was communicated by members of the native fishing community. And of course, there was a little bit of skepticism on part of the colonial elite. So they probably didn't take it quite as seriously as they should have. So the 1902 events actually started quite some time before. And there was already increasing fumarole activity as early as 1889, so about 12, 13 years before. The eruption then kind of developed gradually. That's really what we have to understand today. Over something like 10, 12 years, fumaroles were changing locations between 1889 and 1899, and but the activity is not dramatically increasing. In 1900, it's noted that there's stretches of vegetation in the summit areas that are damaged. So something was going on. And I guess from today's perspective, we would be alert if we see that. During the year of 1902, new vents opened and they emitted sulfurous gas. And this actually made life unpleasant, as it's reported in the villages around the volcano. And then early 1902 up to March, the sulfur smells increase. And actually they were reaching the city of Saint-Pierre itself. In April 22nd, submarine telegraph cables from Martinique to Guadeloupe break. And the cables break on May 3rd and May 5th, other cables. And this is likely either submarine landslides or submarine earthquakes that cause rock falls. And of course, this should alert us. And at the time, it was not considered a major problem. And of course, at the time, it was not linked to the volcano, which is maybe a problem. So seismic shocks then April 23rd felt around Montagne Pelée. These shocks are accompanied by loud explosive noises and ashfall. It's reported that dishes were thrown from the shelves in Saint-Pierre. We now believe that the shocks were caused by initial phreatomagmatic eruptions that were restricted to the summit area. So again, this would be giving us some alert today, but at the time, understanding was maybe not quite as developed as it is today. April 27, an investigation party is sent up to the volcano summit, and they report water fountains from geysers, I think, and in the crater, and a small lake, and that a new dome has started to grow within the lake. So the volcano was starting to push up material from its inside. May 1st, rumbling of the volcano increases now, and it's starting to be quite sulfurous in Saint-Pierre. The air becomes very kind of sulfurous, and then about 1,600 people have left the city at that stage. They realize something is not quite right. And the problem, however, was that a lot of people from the villages around the volcano had no other place to go, and about 9,000 people were actually seeking refuge in Saint-Pierre. So strangely enough, the city's population was swelling instead of decreasing. So May 2nd, frequent loud explosions ring out, and substantial amounts of ash is now accumulating in the streets of Saint-Pierre. And it's reported from, for instance, the wife of the American ambassador, that horses were collapsing in the streets because of the bad air quality due to suffocation. And the new dome has now grown to an extent that it's visible from Saint-Pierre. It's above the crater walls, and you can see it glowing during the night. So loads of people in the city, loads of refugees in the city. So conditions are clearly deteriorating at the time, but I guess we have to accept that there was no immediate emergency planning, no evacuation plans were in place, and this meant many people didn't necessarily have other places to go. So then let's continue with our little time series. There was, to my understanding, a secret order from Paris received at that point, because there was an election planned for May 11th. And the order meant people were supposed to be, or to be encouraged to stay in the city. So the conservative population of Saint-Pierre was needed because there was an Afro-French candidate, and there was possibility for him winning the election. And the governor had already left at that point, and he was supposed to, however, lead by example and stay in the city so that the conservative voters would be encouraged to stay and obviously vote against this Afro-French candidate. At least that was the idea in Paris, to my understanding. So, and that put a little bit of pressure on the governor. He actually came back a little later. And at this point, there was also several newspaper reports. These were supposedly aiming at calming down the population instead of providing factual warning. So official reports are published, and one quote from there is, Montagne Pelée is no greater threat to Saint-Pierre than Vesuvius to Naples. Well, reference is made to harmless Vesuvius eruptions, 1872, 1822, 1794, but there's no mention of the 1879 Pompeii eruption. And sadly, the comparison to Vesuvius was not wrong. It was just incomplete. So now, May 4th, the morning, a plume ascends accompanied by loud rumbling. Tremors continue, continuous ashfall. By afternoon 1500, the plume reaches a height of 9,000 meters. Lahars spill over the crater lake, killing 23 people on May 5th. And May 6th, activity shifts to ballistic eruption of juvenile magma on top of the now 200-meter high dome. May 7th, eruption frequency increases steadily and rumbling is now continuous. So the situation is clearly getting worse, and it's getting worse by the day, judging from these accounts. May 7th, the governor is actually coming back. He escaped to Fort-de-France, the other big city, and he obviously has to keep the city together. So he is actually returning now with his family on May 7th. And at lunchtime, the first smaller pyroclastic flows descend from the summit. And the investigation party, the committee, states the phenomena are not in any way abnormal. Instead, they are identical to phenomena observed e.g. at Vesuvius. Well, sadly, they were right in this statement, but it's not the intention. They didn't mean that really. So here, another kind of image, and this is, to my knowledge, the last image before the devastation of the city. You see the volcano emitting plumes of ash, smoke, and gas, and you see that there's a few ships in the harbor. So then May 8th, the day of the cataclysmic eruption, it was actually Ascension Day. During the night at about 3 a.m., a pyroclastic flow kills 400 people to the north of the volcano. This is not known to people in Saint-Pierre. At 6 a.m. in the morning, ash causes total darkness. So the day doesn't really start in Saint-Pierre that day. And at 8 a.m., the Saint-Pierre's telegraph station signals to Fort-de-France they're ready to receive messages. But at 8:02, the Saint-Pierre telegraph is disconnected. Let's take a deep breath. It implies that exactly that at 8:02, the eruption rushed through Saint-Pierre and it wiped out the telegraph station and the rest of the city. We know from later recordings that a pyroclastic flow is the most likely phenomena, and this image here of this pyroclastic flow is actually from later in the year. It's not the one that devastated Saint-Pierre on May 8th. This was done, this image is from Lacroix, one of the French researchers, and it's from, I think, July or August of that year. So, but there is some eyewitness reports from some of the villagers a little bit further from Saint-Pierre, and they report a massive, dark, very dense cloud spilling over the crater and moving towards Saint-Pierre. It's not a collapsing plume, therefore, not the Pompeii style. It's not going up and down. It's actually more of a directed thing. It's going directly towards the city, and that makes it particularly fast. So the initial cloud shoots over the crater and it speeds down to the city. And apparently, according to these eyewitness accounts, it does not slow down. This is symptomatic of a pyroclastic blast, directed blast. And that means a hot pressure wave that has a direction. And that is obviously particularly dangerous in a case like this. Flow velocities were initially, according to our estimates, about 180 meters per second, meaning 650 kilometers per hour. Whoa, even with a fancy car, you would have a fancy sports car, you would have not made it. This was too fast. Still up to about 500 kilometers per hour when entering Saint-Pierre. And temperature estimates are a bit difficult because much of the debris burned later on, but the estimates range between 250 and 400 degrees C for this hot ash cloud running through the city. So when the rescue teams from Fort-de-France arrived at lunchtime, it was actually so hot, the city was burning, that they could not enter the town because of the heat. They realized already in the morning something had gotten gone absolutely wrong. But when they arrived, they couldn't do very much. It took them until late in the afternoon, about 1500, and then they were able to enter to the outskirts. But they found all but one single person dead. Here is a drawing from a Czech newspaper at the time, and a Czech colleague sent that to me. And this is a sketch showing the French rescue party arriving. Here's the volcano in the background. Here's the burning city, and they're arriving in the outskirts. But the people there are all dead. They have perished in the fire and in the eruption. This is another image from this newspaper, and it shows the erupting volcano here, the devastation of the city and the ships in the harbor. But there's something intriguing. It actually shows lava flows coming down. You can see that here. It doesn't fully appreciate the concept of pyroclastic flows, implying clearly that this was not a well understood phenomenon at the time worldwide. So when people heard about the catastrophe of Pelée of Martinique, the understanding of what actually happened was not really clear. And this is something we need to bear in mind. So here's a few images of the devastated city of Saint-Pierre. And here you see the trees are stripped barren, and the houses are only, well, ruins at this point. Here's a few people for scale, just to give you a sense. In the upper one here, we see the volcano still erupting in the weeks and months after May 8th. So this eruption continued. Here's a few newspaper clips, again from one of the Czech newspapers, but also from a British newspaper here. The wreck of the cathedral, it's called here. And here you see the church tower. And here you see a redrawn photograph of rubble in front of the major buildings. And this is also the church tower here in Saint-Pierre. So here's a few more images just to give you a flavor. And here you see one of the French colonial officers walking along the beach. The trees stripped bare, and there's just a city made of ruins. This may be the most famous image from that eruption. It is, well, just a valley of desolation, really. You see the Rue Victor Hugo there, parallel to the coast. Here's the volcano, and not a single house is intact. Everything is destroyed. So there was this rather prosperous suburb of Fonsecourt, and here's an image of it. And here you see splendid houses and lovely alleyways and things like that. And this is what was left of Fonsecourt after the eruption. It was literally swept into the sea. The pyroclastic flow was so strong that it washed these houses and the streets off the surface of the earth. So destruction from the blast is extensive in the outskirts, and it decreases towards the sea. The blast also damages most of the rum distilleries, and literally tens of thousands of liters of rum were flowing towards the sea. It's well, now important to think of the high alcohol content of the local rum, spelled with an H. And well, rivers of burning rum were reported to have run down from the hillsides into the city. And this caused extra problems because this set the city ablaze after the destruction from the pyroclastic flow. So let's look at the casualties a little bit. This is very intriguing because it's been noted by the rescue team officers that many of the casualties had severe skin burns, but intact clothing. This is really, really intriguing. The French military doctor that was part of the rescue team concluded that most died from suffocation or from inhaling hot ash and having severe skin burns. But the ash cloud was too fast in most cases to ignite the fabric. So this is really an extremely fast, hot ash cloud that has moved through. And this was bad enough to kill the people, but for most things, it was too fast to set them ablaze. However, as I said, the rivers of burning rum came afterwards, and they did a rather unpleasant job of burning much of the city a little bit later. So the members of the rescue team closed, one of the members of the rescue team closed this report with the words, "No living soul appears in this desert of desolation, encompassing by appalling silence." So here's what they would have seen, a witness of the Saint-Pierre horror here. As it says here, you see the corpse of a burnt corpse of an individual. And here is a French rescue team member. And this is in one of the houses. And here you see a mother and her children being dead. But you see the bottles are still standing on the table. So it was actually not the pressure wave that was acting inside this house. It was the hot material, the hot ash that was infiltrating, and this was what was causing the damage. And well, this is what was killing the people effectively. So when we look at some of the relics that have been recovered there, so here we have some metal relics. There is, for example, a box of scissors, probably from a metal shop, that was welded together from the heat, and a box of nails here, again welded together. This is likely from the secondary burning. And in many places, we see these deformed bottles and glasses, and this means that heat was quite intense in order to do this to as hot as molten glass. And this, however, is not strictly from the pyroclastic flow. This was likely partly from the subsequent burning caused by the rivers of rum that were flowing into the city, setting things ablaze after all. Even if the pyroclastic flow didn't quite manage to create fires all through the city, the subsequent events did. Now, some of the ships in the harbor were, of course, affected by this as well. Some escaped. There's this intriguing story about a Swedish sailor who survived on one of the ships outside, and he gave an interview in the late 50s when he was very, very old. And I actually just got a copy of this interview from one of the radio people here. I have to listen to it more carefully. It's quite fascinating. But they're out there in the harbor area. There's still some of the sunken ships. And here is a ship bell from 1862. So this ship was 40 years old by the time it sank. And this is now out there in the harbor area. And here's another ship bell that is heavily crushed from the collapse of the ship. So there was this survivor here, and this is a very intriguing story. Ciparis, as I think he's pronounced, and he is widely considered the only real survivor of the catastrophe. He was actually imprisoned at the time. The story goes that he was a thief, but he was then sent for community duty. And while he was on community duty, he got into a fight with some other criminal, to my understanding, and the fight led to the other guy falling over and dying, or something like this. So anyway, he was accused of murder. Whether he's really a murderer or not, I don't know, but he was accused of murder because of this, and then he was put into an isolation cell, and this is the isolation cell here. So he was in this, and the only real outside connection he had was this little window. The door was closed, and well, because of this poor ventilation, he survived. He was badly burned after all, and it took months for him to recover. And because of this, he was actually rehabilitated. And he later went to the US, and he became a member of traveling circus, and he was the man that could withstand the volcano, the eruption. But apparently, my latest investigation tells me that he nevertheless died poor. So he never really, I guess, recovered fully from this, and he never really kind of got his life back onto full track, even despite his activity at the circus. A somewhat weird, but maybe also tragic story. So anyway, he was the sole survivor to the best of my knowledge. Some people say there was an old granny that survived as well, but I couldn't really find a lot of details about her. So then here's a few impressions of the theater. This is the theater back in 1901, I think. And here's the theater ruins when I visited a few years ago. So the front of the theater was turned away from the volcano. So the blast came from behind the theater. And here we see that the deposits, this is the deposits from the volcano. They were coming from here and deposited after the theater. So the front area of the theater, the nice stairs here, they were actually turned away from the volcano, and that acted as a sediment trap for the volcanic material. Much of the volcanic material rushed out into the sea, but we have a bit of the sedimentary material in front of the theater. So because of this weird construction of the theater, we have a bit of material here. So here's one of my colleagues acting as a scale, and here's the wall of the theater. And here you see the deposit layers. And here is the roof tiles at the bottom, which would be down here, is the roof tiles of the theater. They were taken off the roof and then deposited as the first material. And then the volcanic ash was then deposited on top, and there were several pulses then. So this would, however, be the one from the day from May 8th, and then there was subsequent pulses being deposited on top. So we have a little bit of the eruptive material from that eruption. And here we see a friend of mine trying to dig out some small materials right from the blast deposit here, from the very lower layer here, just after the roof tiles. And this is the pyroclastic deposit from May 8th. So what happened then after the eruption? Well, following May 8th, another plume rises from the volcano. More pyroclastic flows follow May 19th, May 20th, June 6th, July 9th, and August 30th. So the latter flow also destroys the village of Montrouge, causing another 1,000 casualties. This brings the total to something on the order of 30,000 casualties during the 1902 events on the island of Martinique. So here is a few impressions, and here you see the volcano kind of erupting while the ruins of Saint-Pierre are at the volcano's feet. And clearing the ruins was a bit of an issue. I mean, things were really kind of in shock and awe, if you will. The ruins actually developed into a tourist attraction, and Saint-Pierre never fully recovered from this event. Today, it's only about 7,000 people living there, which is only a fraction of the population from 1902. So here's a few impressions from the ruins and from the clear-up works. So here people were writing postcards from the site, and you see local people clearing up and other people standing there with umbrellas and watching them. And here you have some colonial officers posing in the ruins. And I guess, yeah, it shows that this was developing into something else after the eruption. And while clearing work was happening, it didn't quite go to the extent that all was uncovered. And having just been involved in the La Palma eruption 2021, I guess some areas will also never be unearthed again. They are just under the volcano. And looking at, for example, the Timanfaya eruption on Lanzarote, there are still villages buried under the lava. Sometimes new villages have cropped up on top, but some things will never get unearthed again. So here's a few impressions of the ruins from my visit some years back, and now they're partly overgrown. It's very scenic on the one side. It's a bit eerie on the other side. So I'm going to run you through some impressions now. Here's some of the large storage houses near the former harbor areas, and some of the more fancy houses with nice kind of, carvings and things, entrance doors. Here is some of the storage areas again, and some areas have, as I said, never been fully cleared up, and you see columns lying there as they fell, I guess, and they are still a reminder of the destruction of that time. Now I should say a few words about the Great Spine. It's actually not the spine that caused the problem. although a lot of people think so. The great spine came a little later. During the summer and autumn of 1902, the dome continues to grow, and only in November that year, a great spine was pushed up. So here is some of the early impressions of the great spine, and then it was growing really, really tall. And this is a bit like, yeah, I think sticky toothpaste being squeezed out of, a container. And here we see the final size of it. It grows to a height of 350 meters, but it crumbles already in early 1902. It's almost completely gone in spring 1903, and a small-scale dome growth and minor pyroclastic flows continue until 1905. So the spine started to really grow in late 1902, and it crumbled by early 1903. So it had a lifetime of about maybe half a year at best. So the French population considered the spine as the ultimate symbol of Montagne Pelée's victory over civilization. And here we see the ruins, and here's a photo with the spine, with the volcano. The volcano kind of was, yeah, sticking up a finger, you could say. Some people like to call it this. I think it's a very strange kind of a situation where the volcano is showing its magnificence towards the city after having caused all this devastation. Clearly, the power of the volcano was absolutely overwhelming, and there was very little, almost nothing that people could do. So an observatory is established consequently in 1904. People realized that something needs to be done, but unfortunately, it's dismounted in 1926 because of a lack of activity. And then there was another eruption in 1929. So I think people didn't fully realize that volcanoes operate on different timescales than humans, and that causes us today to realize that volcano observatories need to be permanently manned and need to be active for a long time. So what went wrong in Saint-Pierre? Well, there was limited understanding of the long-term record of volcanoes, and inappropriate comparison was made. Although they chose the right volcanoes, like Vesuvius, they didn't fully look at the entire history of the volcano, and that led to a lot of confusion at the time. Then no evacuation plans existed for the population, nor facilities. And this posed not just a psychological, but also a logistical problem for the people of Saint-Pierre. Obvious warning signs that we understand today a lot better were either purposefully ignored and or because of a lack of knowledge. And it seems authorities also gave false assurances, probably because of some political interest by some people at the time. Well, there is an element of saying, oh, they really did a poor job. And I think we have to be a little careful, however, because I think the other realization is that looking at the newspaper reports, looking at the images in the newspapers, I don't think people understood really what was happening there. I don't think people were prepared. We call it the black swan event, something that is coming completely out of the blue, something that nobody saw coming. And I think for the authorities there, this was a bit of a black swan event, something they had not thought about, something that was not prepared for. So, and now a few words about the eruption and what triggered the eruption. And here I collected a specimen from the dome area, the 1902 dome. And here's the same specimen cut up, and you see these blobs in there. So the rock is a dacite, the pink rock. It's a medium to evolved andesite to dacite type system. And here we have these blobs, basaltic blobs in there. And these are round, but they partly solidified. You see the dacite material infiltrating it, and there's a bit of a chilled margin there. So this implies that there was fresh mafic magma coming into the volcano, likely in the years before the eruption. And this would be a key trigger. So I looked at some of the crystals here, and here we have some feldspar crystals from the dacite. And you see zoning here. So here we see a core, and then we see concentric rings around it. But if you look very carefully, there's some anomalies here. Well, this is the same crystal, just turned a little. And here you have this core, an older core, and then subsequent concentric rings. But then something here is a bit odd. There's a wobble in the rings, and I got really intrigued by this. Now, let me quickly talk a little bit about feldspars. This goes back to some work I did on actually on the Isle of Rum in Scotland many, many years back. And there we also have these blobs in some of the, in this case, rhyolite eruptive rocks. And here we have feldspars. And once you get a feldspar into this blob, it starts to be eaten up. It starts to be resorbed. And you can read this up in one of my, actually, my very first paper, Trollodal 2000 in Bulletin Volcanology. And if you then let these crystals sit in there, they get strongly resorbed, they get rounded, and they dissolve because of the heat and the aggressive chemistry of the basaltic magmas. So, and if this game goes further, they almost completely dissolve. But if the heat of the basalt is insufficient to completely dissolve these partly resorbed crystals, they start to overgrow again. And this is what we see here. Here we have a euhedral crystal that has grown again, and it's resorbed in the interior. So this chap here, this crystal, recovered from a resorption event. So the implication is that in this particular case, there was a replenishment of mafic magma. It started to eat up the crystals, but at some point, the crystals started to regrow. And they were not eaten up completely. Now, when we go into a little bit more detail now, and this is the crystal I showed earlier from Montagne Pelée, and we look at this here, there's actually a little resorption here. We have an indentation in that zone. So this crystal in that part here was actually eaten into, and then it was overgrowing. And this implies that there was resorption events. And also looking here, the area here is a bit rounded and not kind of fully edgy. So it's not a well-developed edge. So we have to really think of multiple replenishment events that occurred into the volcano's magma chamber, into its reservoir in the years prior to the eruption. If you think about that, these kind of rims take a few years to grow, then that would make sense. And my suspicion is that this material arrived in those 12, 13 years when the volcano was starting to develop unrest prior to the eruption. And this is reflected, of course, in its crystal record. So multiple replenishment events seem to be recorded in the crystal stratigraphy, helps to determine the PT conditions, and also it helps to give an idea what happened with the volatile budget inside the volcano. Now, what do they do, these basaltic replenishments? Well, they bring new volume, meaning the volcano is likely to bulge up a little. They remobilize the resident magma by heating it, and they degas on entering the cooler, lower pressure environment inside a high-level volcano magma chamber. So, and that leads to gas overpressure, and eventually this leads to an eruption if there's sufficient replenishment happening. So this goes back to work by Steve Sparks. And here we have a reservoir, very simple cartoon. We have a reservoir with resident magma. We have basaltic replenishments being pumped into this. And then we start to stir this up by heating this. This will take a little bit of time. It's not happening overnight. It's likely going to take months, maybe years even. And eventually this system will start to develop gas bubbles down here, and they will start to rise through the system. And eventually this whole thing will inflate and overpressure, and this can cause an eruption. As I said, for small volcanoes, this process would take years. For large volcanoes, it may take hundreds of years. And a few years ago, there was this rather famous article on some of the supervolcanoes. And here it's discussed that actually it may take 100 years or something like this for a large volcano, the unrest period. But for small volcanoes, it's only going to take maybe 10 years. So Volcanoes show unrest in periods prior to the eruption. Residence times from crystals suggest 10 to 100 to 150 years, depending on the size of the volcano. And that is the time we need to use to prepare. And that is actually the time that was provided by the volcano in the Montagne Pelée case. We had unrest signals 12, 13 years before already. But unfortunately, this was not understood and the time was not used to prepare evacuation plans, facilities, etc. So what have we learned? Well, we need to study the long-term history of volcanoes to understand eruptive histories. It's a bit like a medical record. You need to understand the problems a patient has in order to make predictions of how things might go and also make preparations of how you can help the situation. You need to learn to compare eruption histories with similar systems. And similar systems in that case would be something like Merapi in Indonesia, Unsen in Japan, Soufriere Hills on Guadeloupe. And then you can derive a useful conceptual framework for what the possibilities are in terms of the volcano's behavior. Maintain continuous volcano monitoring is another important thing to do. And of course, there is now a volcano observatory. And there's the second volcano observatory and the Montagne Pelée one. And this needs to be permanently manned and there needs to be observations. You need to create baselines and you need to see when the volcano is behaving differently relative to these baselines. This would include temperature measurement, seismicity measurements, heat measurements, inflation measurements, and all these kind of things. And when several of these parameters start to become untypical, when they become abnormal, then you need to be putting the alert into place. So multi-technique approaches are therefore required, including these things I said, but also gas. And these days, even more important than back then, we have more and more remote sensing things, not just looking at things, but also we have radar measurements now, INSAR looking at deformation remotely. So you don't actually have to go up to the volcano all the time. You can actually look at it increasingly with distant methods, and they will tell you as well if the volcano is doing something. So let's hope Montagne Pelée will not do anything for the anniversary. I hope it stays quiet, but if it wakes up again, hopefully it will give us another period of several years to prepare for things. And I'm very confident the authorities are now a lot better prepared than they were back then. Thank you for your time. All the very best and good luck.